Lunch and Learn. It's a podcast and YouTube presentation of the Arkansas HVACR Association. We dig into code and talk to experts about their products and perspectives on the HVACR industry. We're Arkansas based and focused on Arkansas concerns. Today, we're going to take an in-depth look at commercial kitchen hoods. Now, some of you probably already an expert in this field, but I know some of you do heating and air conditioning residentially, and you probably from time to time have a homeowner say, "Hey, we're getting ready to do a restaurant. Can you come down and help me out?" Of course, they do that because they're hoping that you can save them some money. And if you've launched into this area of our industry without any training, you know that it's a little bit more complicated than it might just seem on the surface. That's why we have Ryan Leonard and David Terfe of the North American Kitchen Solutions on Lunch and Learn today to fill us in on the do's and the absolute must-dos of kitchen hood design and installation. Welcome, Ryan, and welcome, David.
Excellent.
Hello, Tom.
Thank you, guys.
David, you're going to be kind of running this show today, so why don't you just start off and begin by telling us first who in the world is North American Kitchen Solutions, and then you get into what we need to know.
Yep. So we're a regular standard hood, ventless hood, and back of house fabrication company. So we handle everything from the ductwork, the exhaust fans, supply fans, any variants of those hoods. We offer a lot on that side as well, and we offer a full gambit of ventless hoods. So it's
Gotcha.
definitely a wide range, and we have four factories, 2 in Cleveland, Ohio, 1 in Atlanta, Georgia, and 1 in Dallas, Texas.
And Ryan, you're national sales manager, right?
One of two. We actually divide them into East and West.
Okay.
So I'm now tagged as West, and I am the national sales manager to handle any issues that might pop up. We can certainly guide you guys and help you through.
Well, when we're finished with this, David, Ryan, be sure to tell people how they can get in touch with you. So let's get the show on the road.
All right. So I'm going to talk about the exhaust systems and supply systems on kitchen hoods. Right. One thing sometimes people do is they increase the air too much, create a big negative draw in the space. They're trying to help, winds up hurting. Hopefully it doesn't hurt as bad as this, but it tends to not be beneficial for the restaurant.
You got to love this guy, right?
Or the fact that the guy just keeps eating.
Yes, sir.
So some of the important areas to watch, first and foremost, so all of our hoods, we go to UL, and all of our products are UL listed. We sit on the boards of some ASHRAE and ASTM committees to make sure that we stay abreast on any type of fire safety prevention. When it gets to the ASHRAE standards, the heat, humidity, comfort, and then energy savings as well. So we try to make sure that we're abreast on everything so we can try to help you guys as well. One of the big pushes lately has been like CKV. So that's a commercial kitchen ventilation. They do a lot of energy monitoring and modulation, things like that.
You got to have an acronym, right? You just got to have an acronym.
Yep, and kitchen hood modulation is known as DCKV, just to add one more into it, right?
Okay.
Demand control kitchen ventilation. So hoods, if a hood is either UL or ETL listed, it's been tested and certified how to run and provide a safe circumstance at the lowest CFM possible. What that does is saves the customer a lot of energy on the back end when they're running their restaurant every day. They're not pulling out all of their makeup air, all of their air-conditioned air, all of their heated air. Makes the kitchen a lot more comfortable. Again, life safety, that's number one on our side. And then you get into the monitoring, system controls, building modulation. There's a lot of that. Back neck, Modbus, things like that is even more acronyms.
Okay.
Codes are always important. We want to make sure that whatever we're doing, we're following. Any hood company should always be following their UL listing. There's a sticker inside the hood that tells you exactly what it's rated for. Then you have your local codes. For instance, in Arkansas, you have IMC 2021 is the version that's approved currently
Mhm.
statewide. And then we'll dig in real quick on makeup, air, and exhaust fans and all of those items listed there. Again,
Well, I know we've got more codes than you can say grace over. So I think people can look down this list really quick and say, oh, Lord, surely not.
yeah, and even on some of the code committees that I sit on, we're trying to, there's a unified mechanical code that we're trying to bring everything under one umbrella. It's very difficult, though, because everything was fragmented before, but we are getting more and more aligned, which is beneficial to everybody because it's less that you have to watch. Right, and then you get into the design standards. So when people are laying everything out, part of ASHRAE, which is the American Society of Heating, Refrigeration, Air Conditioning Engineers, there's a design book, and it tells you, it pretty much walks you right through a hood design on what you need. We call it a cookbook, if you will, but it lets you know what to do for ventilation. Testing. So when you go out in the field, and I believe Ryan and I were talking about it earlier, I think that since the 2021 has been accepted, it's actually 507.6 and 507.6.1 capture and containment test. So it tells you how to make sure the hood's capturing. You can design a hood for whatever you want. I lead our engineering team on product development and regulatory side. It really matters what happens in the field. As long as it's designed well, it should capture and contain well. But if someone drops a duct in the wrong place, there's a door that people are always coming in and out of, some other circumstance that maybe it wasn't designed the best, this capture test really shows you what the hood's doing and make sure that you're operating above the minimum for velocities.
Okay.
Velocities
Let me ask a question here, David. If I
yeah,
understand this down here in the red, it says that, and this would be code, you've got to have a visual inspection. Is that correct?
yep, that's correct.
Wow.
And
So a good old boy goes out and throws up a hood that he bought from the local used restaurant supply place and slaps it up there and runs off thinking he's done everything. He hadn't done everything, has he?
he hasn't, and it's important to make sure that when you're doing a capture containment test, that the equipment's on. What happens with airflow, when air gets hot, it becomes very sparse. It's hard to capture. And the prop up in the fan, the impeller, winds up almost cavitating like a boat prop. So if it's not designed correctly. So when you do a smoke test, you make sure everything works. It's important to make sure, like it says there, conduct with all the appliances under the hood at operating temperature. Because that's what will give you the true results.
And if I may just throw 2 cents in, I always recommend to the installers, do this test prior to calling for your final, because then you're going to find out, oops, we got problems, and then you can correct them before the final inspection comes, and then you could possibly fail the final inspection. So this is something I would also put upon installers to pre-do before your final.
That's a great point. That's very true. And to give you an idea what it looks like, so when you're doing a visual test, you get that smoke going, you want to see a nice pullback. Generally speaking, a nice design, you'll see it hit the bottom, like half of the filters. As it starts to wander up and get pulled into the top side of the filters, you're getting ready to lose containment. It'll start filling the chamber, and then if it keeps billowing, you'll get it rolling out the sides, and you fail. So just before the test, like Ryan was saying, let everything run your test, make sure everything's operating, and try to do a visual and see if that air is hitting about halfway or lower on the filters. So one of the tough things, and it's hard without smoke to see airflow, and so we have imagery that we use, so this way we can see what's going on. So this was done at what's called the Food Service Technology Center. It was part of Fisher & Nickel Labs. It's now Frontier Energy. It's where all of the hood companies, we go to get our hoods tested. Certifies everything's working well. So this is a view of, this is what the air looks like. When I was talking about being turbulent and being very sparse, that's what you're seeing there is the actual, what the air molecules look like as they're going up. Almost like when you look out like on a car hood or the asphalt in the summer and you see it kind of rippling, you're seeing the same effect. One important item, and this, I think, I don't know, Ryan, it's probably been the last 15 years, although it still seems like it's not necessarily being taken serious all the time, is end panels. The little quarter end panels to go on the sides of the hood. That's what that triangle piece of metal is there. It doesn't matter the hood manufacturer. Whoever they are, they almost everybody uses them now. If they don't, they should. When we were going through our redesign, we had a basic hood, flat bottom, not super efficient. We went through, redesigned it. We had internal baffling that we now put in. We put side curtains on. We have baffling on the intake air on the front. And really took us about 2.5 years of engineering time. And in the end, the end panels was the #2 biggest change that we made to the hood to make everything work. And those can also be put on older hoods. If someone's having a problem with capture and containment, look at just putting a little 23 by 23 little triangle on the side. It's just a great help.
Yeah, and I'll throw my 2 cents in on that particular still shot. It's also a video that shows the hood leaking. And then you see in the foreground there, a guy walks in with those end panels. And they put those end panels on, and almost immediately the hood starts to capture and contain just by putting those end panels on. So that's how important blanking off the sides, left and right of the hood are. Best way I can explain it is it forces more air to go on the front side of the hood, and more air on the front side helps, for lack of a better word, push into the hood and keep it from spillage.
Wouldn't have thought of that.
So another big item is the overhang. So this is an actually think that might be Richard from the test lab. We're doing a ventless project with him now, but he's a great guy. He's been there for years. The oven. So if you only have 6 inches, right, that's 6 inches minimum. Convection ovens like this, if you only have 6 inches, all that turbulent air, if you look like right in front of his head, right to that little corner there of the hood, that air is just dumping out the front. You're dumping all that heat. Right, convection ovens, they won't have that much effluent, that much greasy effluent, but the turbulent air and the heat that goes into the room space is a lot. And then the air conditioning has to try to keep up with that. So when you're putting equipment in and you're doing these tests, sometimes a piece of equipment might need more overhang like this. I can see 18 inches and it's coming up. You see a little blurb on the front. It's a little kickback, spirals, and then it captures and goes in. So it's always important. Every site can be different, especially all the equipment, right? Like when you look at the equipment, there's such a gambit, right? Running from 400 to 700 degrees. And this is out of IMC on what kind of qualifies as what type of equipment. We kept it simple on our hoods. The NACS hoods are all listed to 150 CFM a foot. We kept it the same across the board for minimums because we want to make sure that everything's in the field working well and people aren't trying to turn stuff down even more. So worst case, we passed the UL test at 150 a foot, and it's just, it helps you figure out what you need out there based on these. And we'll get into some more CFMs a little bit further in. Tom, you're talking about, what's that?
And I would just quickly add that this is why the salespeople will always ask you what's your appliance layout under your hood. And when you don't know, it makes it difficult. So we have to assume the worst. So then we're might be unfortunately increasing CFMs when we don't need to. But we can always verify appliance layout before any ordering is done or through submittal process. But up front, yeah, we like to have that info up front, possibly. So always try to get your appliance layout from the owners. Doesn't necessarily need to be in order. We just need to know what's under it.
So items to watch for on the listing side. So if you have a listed hood, ETL or UL listed hood system that's been tested to the UL standard of 710, and it's been installed in accordance with how the listing is, there's certain items that you don't have to worry about as much, right? That's kind of the nice thing. Not only do you get lower CFMs, save the customer money, but also you don't have the concern necessarily or the weight on your shoulders of making sure all of these things are right? The type of material that you're using, the joints, any seams, right? Because the hood has to be fully welded if it hasn't been fire tested. The grease filters, the size, the location, quantity, the duct, the locations, calculations for the rates, right? Not just the location left to right, front to back, but then the size of the duct. And we'll get into ductwork too in a minute. And then, right, just the location of any of those parts. In general, kind of a broad brush stroke here. When we look at the equipment, we saw the different types. So light, medium, heavy duty, extra heavy. There's the wall mounted and the back shelf hood. We're just going to take those two, right? There's eyebrows, there's passovers, there's a bunch of others, but these are the main ones you'll see in the field. So generally speaking, unlisted hood, you're going to be anywhere from 2 to 550 CFM a foot. And this is to make sure that it's functioning, working, and everything's good with your smoke test. To anyone's listed hood, it'll be 150 to probably 350, maybe 400 if you're, say, an island style and no walls on any sides and you're at extra heavy duty. So this is just some of the items to watch for, and as you'd need less CFM, depending where you're at, it's roughly a ton of air conditioning for 500 CFM. And if, say, you have a 10-foot hood, right, you could wind up saving your customer 5 tons of air conditioning, depending how everything's run. So just some items to watch and where the benefits and the cost savings come from after the project with listed products. We took a general kind of picture here, right? We have our hood system, we have our 3-inch standoff, we have our UL listed filters, the grease drain cup, and then we have a mechanical baffle in the front of ours. And that baffle really helps kick the air back. That was the number 3 big change that we made on our hoods, was that mechanical baffle inside. It really helps bring that air back and lets it start capturing and pushing in. So kind of gives you an idea.
David, I have a question for you right here. You were talking about this built-in 3-inch rear standoff. So you've got to have 3 inches between the back of the hood and the wall itself. Is that right?
Depending on what the wall is made out of.
Okay.
That matters a lot, right? If it's going to be a concrete wall, typically a 3-inch standoff will be required, so you get a little bit of airspace. It's not always. You usually want to have a little bit of space though, just to make sure you're not having all that heat right on the wall, because it can just start radiating through the wall, causing other problems, wiring behind it. If you have a wood wall, you say they have wood, they threw plywood over it, and they put a sheet of stainless, and they're like, okay, we're good. You're not good. You're going to need something with 0 clearance, a listed product, or you're going to have to tear all the way down to the studs and build out with metal studs or a couple layers of gypsum board, and then 2 layers of metal. So that's also in the IMC. It shows you how to do clearance reductions. Make sure you look at that before you try to put any hood up, before you bid a job. Very important. And if there are any inspectors online, to make sure you watch for that. It's definitely critical. It's easier, even if the hood's already up, it's better to handle it now than have something happen later on.
Wow. That's serious.
Yeah. We've run some tests, and maybe at another time we can share some of our test videos where we've had to, when you have a listed hood, you have to bring it to failure. So you have a 13-inch diameter pot, and you have oil in it, and you catch it. The oil has to combust by itself. So once it ignites, all the oil has to drain out. and you have to run it with the fan on, pulling it all through the ductwork, and the whole inside the hood is slathered with lard.
Hmm.
And then you have another one where as soon as the fire starts, you have to kill the exhaust fan, and you just cook the hood to make sure your structure is good. So that's really why you want that standoff, is to, if anything ever gets up behind those filters, grease filters are really meant to, they're really fire stops is what their job is. So, but if something gets by them, say you have a filter that's out of place, maybe they took it down because they were cleaning at night, you don't want to run a chance of getting that wall on fire. The kitchen makeup air, and this, you can see the quarter side curtains again on these ones. Good way to reduce and make sure that you're not pulling out all of the air. Is not only that, but making sure that you have listed hoods, which you, not to beat that into everyone's head too much, but it's very important with all of that. Right. IMC gives you a requirements for duct sizing, right? So the slower you move air, the bigger your duct. The faster you move air, the smaller the duct. So between IMC and NFPA 96, they give you the rates on what your exhaust flow should be. Right? You can't be slower than 500. You can't be more than 2,500. The reason is if you get below 500, we've seen that air starts or grease starts falling out of the airstream. It sticks to the duct a lot more. If you're over 2,500, as the air takes a turn, it also pulls it out of the stream, but then it gets into the duct, and you wind up with these caked-in corners of grease. So it's important as you're laying out the ductwork to make sure of where it's going and how big it is, obviously. Makeup air, all kinds of different makeup air, right? There's a transfer air where all the air is in the front of the house and it gets pulled through. There's ceiling diffusers. There's regular, like the 4-ways. There's 3-ways. There's perforated, back return plenum, air curtain, front face, short cycle, and PSP, which is probably the one everyone's the most familiar with, as the front perforated plenums that blow down on top of you. Downside of those is they make you really uncomfortable if you're not conditioning the air, and they actually are now without conditioned air. IMC code doesn't allow those. You have to have conditioned air. Some short cycle hoods, like the ones that we offer, they don't affect the room space. And we've had it, like ours are tested with Fisher Nickel or with Frontier Energy to show that. But just something to watch as you're bringing the air in different places. One easy way to know if there's a makeup air problem, if it's telling you to pull hard on the door, or you've ever walked up to a restaurant, you pulled on the door and it doesn't want to move, that's a sign of negative pressure. I remember, I guess my daughter's almost 17 now. It had to be 8-9 years ago, and we're going into a chain store for dinner, and she comes up and she pulls on the door and she goes, "Is that negative pressure?" And that's when I realized I talk about work too much. So, but she's grown up around this stuff, so she knows what it looks like too. But that's typically when I go to a restaurant, if we're doing a startup and we're getting everything going, once the hood's capturing containing and now we're adjusting makeup air, we take all the readings, and then I usually use a napkin at the front door or back door to see if it's blowing in or blowing out. If it's blowing in, we're still under negative. Maybe the rooftop units need to be adjusted, some other things. So the best tools in the world sometimes is just, your hands and napkins, something small. You can at least get through the problem or find a solution to get till you can get the right tools on site. But when you're looking at hoods, usually hoods 42 to 48 inches for the top of the appliance to the front leading edge of the hood. So that gives you an idea of how much height you're going to need. Most hoods are 24 inches tall. And then 6 inches of overhang left and right. There are occasions where you can use different types of side curtains, and we can reduce that some, but 6 inches is safe. So however big your appliance line is, add a foot, and then that gives you the hood size. So if you have a 5-foot griddle, don't buy a 5-foot hood. They have a 5-foot griddle, 6-foot hood.
Oh, and I'll throw in some building codes also require that you be 6 inches off the wall So if you had a wall on the left and right, you might want to pay attention to local building code. Some appliances are required to be at least 3 to 6 inches off the wall. So when they say, "Hey, we don't have to worry about the 6 inches because we got a wall," well, no, you still might have to worry about the 6 inches.
Hmm.
It's the one thing we always try to ask when we do hoods between walls.
Yep, that's a great point too. I want to speed up a little bit here because I know we're running a little short on time. There's a lot to cover on hoods. Sorry if I go too fast. Always happy to try to get a hold of. We'll let you guys know how to get a hold of us. Sales@naxinc.com is a great way. Happy to help you guys if you have questions. And we'll cover that again at the end here. So like this is an island hood. So front and back, you want at least 6 inches. We like to see 12, but a minimum of 6. Make sure you get good capture of that. So that when the air comes off the range top or the griddle, it's almost like a plume, right? It pulls in for a second and then wants to go back out. So when it wants to go back out, that's when that 6 inches lets us capture it and pull it back in. Makeup air. You don't want to do this. This is not an engineered system, right? It probably makes them feel a little bit cooler, but you're going to wind up causing a lot of issues in the field if you have this type of setup. It'll create negative pressure on the front, and yeah, please don't. So IMC code says that basically the air, you need to be able to be approximately equal to the amount of exhaust. And then more important with this also is, I think it's on next slide. I guess it's, oh, it's on next one. All right, I went way too far. There it is. So this one here. So with and I'll go back to the others. But the commercial makeup air, want to make sure that it's not more than a 10-degree difference. Exceptions to that is if it's either part of the air conditioning or if it's not changing the room, the conditions of the occupied space. All right, so keep that in mind, conditions of the occupied space. The reason I say that, we're going to back up here for a second. So items like this that are pushing out into the room space, they're going to affect the comfort of the room. So that needs to be conditioned within 10 degrees of whatever temperature it is downstairs. So if it's a 75-degree kitchen without the equipment on, the makeup air can't be above 85. Now, if you have a hood system that has like a short cycle, we call it IPS because we have an internal perforated supply that's bringing the air back in. It's important to know that that isn't affecting the airspace, so you're able to bring air back in that way. Over our time in our engineering, we've been able to, where this, and because this is more of a widely accepted diagram, but the room space of 3,500 and the makeup air 1,500 being 5,000 exhaust, our testing showed that we didn't need that, which was a great thing because we were able to decrease exhaust without affecting the room space. So just some fun things, and we're happy to share any of the documentation or anything else with anyone after this. We'll get some other little interesting slides. If you ever see this, right, this is not good. It's those four-way plenums, they shoot against the front of the hood, create a negative space on top of having a perforated supply plenum, and you'll just suck the air right out of the hood. You'll create a negative space about the first 3 to 4 inches in front of the hood, and you'll just pull the air right out. You have great exhaust, and you'll still not get captured like that. This is an example of what happens. You can see right here, this little curve right at the front leading edge. It's just pulling the air out because there's a vacuum there. So that's, and then we have where we've been able to have a good capture containment with the short cycle hood to get the air pushed back. And the most important thing we did was the air actually gets more dense. So we're actually affecting air density, which was definitely a different way of attacking that problem. And so the other thing just kind of helps direct the air up and out. You can see the air is hitting about halfway up the filter. That's usually a good sign. It means that you're capturing like you need to and like you want to. Perforated supply plenum, something you see a lot in the field. Kind of touched on that. Again, it kind of blows down, really winds up hitting everyone, and about 50% goes into the hood, 40%, 60% goes to the room space, roughly. Again, bad capture containment.
Hmm.
This is what it looks like. It affects everything. You'll have TVs go out that they're using for menu boards now. You can have equipment failures. You can have refrigerated bases that go out as well. And a good sign when you're getting good capture and containment in the field. Last item that we have here is grease duct. There's listed grease duct. Ours is UL listed. Not ETIL, sorry, it's a typo there. But we have a slit fit connection, so it's conical shaped. And what that means is you don't need to get somebody in the field that welds. You can just bolt everything in place. And we found that it drops a job site timeline down by about 4 to 5 days, which can be critical as you get towards the end of these. You don't need anyone to weld. And even our hood connection is a bolt-in connection. So just something to watch. It helps with inspections too, because as long as you install it per the manufacturer's instructions, usually the inspector will just do a light test, make sure things are good, and then move on to the capture and containment.
David, the one thing that I think is going to confuse me most, and I know our guys really need to get your help on, is that 10-degree differential that you were talking about a while ago. I'm
Yep.
still scratching my head over that. Can they contact you and find out the information that they're going to need to be able to use your product or do whatever they're doing correctly?
Yes, 100%. Yeah, if they reach out to us at sales, so SALES at NAKS Inc., so NAKSINC.com. Happy to help.
Well, I appreciate you guys. And Ryan, you were a huge help in trying to bring me up to speed somewhat with this program. And I appreciate it, David, you coming in and helping out with the actual presentation of it. And I can say one thing's for certain. If I was a heating and air conditioning contractor and I was offering heating and cooling equipment to a residential customer and they said, hey, would you come over and put in a Vent-A-Hood for my restaurant? First thing I would say is, I got to call those boys that was on that luncheon order because I'm not really sure what I'm going to do. So give us that contact one more time.
Yep, it's sales, SALES, at NAKSINC.com.
Well, again, I appreciate you very much. And for everybody that has tuned in today, we really appreciate it. And if y'all would give me one more slide progression there. If you've got code questions, hey, we're a team, right?
That's right.
If you've got code questions and you want to know more about this or any other subject, we've got the absolute best inspectors and the best staff in the state up there at the Department of Labor and Licensing. You can call them at 501-682-9201. That's 682-9201. Or even better, send them an email at adll.hvac@arkansas.gov. One more time, adll.hvac@arkansas.gov, and you'll find that the most patient people in the world are there to take your questions and give you an answer. And so again, we thank you very much. Thank you again, David. Thank you again, Ryan. And we look forward to visiting with everybody again in the month of September. Having said that, y'all have a great month. Bye now.